During this segment, we'll talk about slope, and we'll also discuss slope as a rate of change. You may have noticed by now that different lines tilt differently. We measure the tilt of a line by a number, and we call this number its slope. How do we measure slope? We measure slope as a ratio of vertical change to horizontal change in moving from one point to another point on the line. So let's look at a diagram. Here we have a diagram. We have a point labeled x sub 1, y sub 1, and a point labeled x sub 2, y sub 2. Now the vertical change, or also the rise, can be found by the difference of the y values, y sub 2 minus y sub 1. The horizontal change, sometimes called the run, can be found by the difference in the x values, x sub 2 minus x sub 1. So that's how we find the slope of the line containing the points x sub 1, y sub 1, and x sub 2, y sub 2 is, now we use m to denote slope. It is equal to rise over run, which equals change in y over change in x. And we find that by y sub 2 minus y sub 1, the change in y over x sub 2 minus x sub 1. This is, of course, as long as x sub 2 is not equal to x sub 1. So let's use that slope formula, and let's find the slope of the line through these 2 points. To do so, first let's find the coordinates of the points. This point has coordinates -1, 3, so -1, 3. And then this point has coordinates -3, -2. So -3, -2, excuse me. And now we'll use the slope formula. And to use the slope formula, remember it's difference of the y values over difference of the x values. And we use the letter m to denote slope. So difference of the y values. Now it makes no difference which y value you start with in the numerator, but whatever y value you start with in the numerator, you must start with the corresponding x value in the denominator. So slope is, I'll just start with this y value, y minus y, 3, over, now I started with this y value, so I've got to start with this x value in the denominator. Be very careful, x minus from the formula, and then this x value is -1, so minus a -1. And now let's simplify. -2 minus 3, that's -5, over -3 minus a -1, that's -3 plus 1, and -3 plus 1 is -2, and then a negative divided by a negative is a positive, so I have +5 over 2. So the slope is 5/2, and I want you to notice something. We have a positive slope, and as you follow this line from left to right, very important, as you follow it from left to right, notice the line is increasing. That will always happen with a positive slope. Let's now find another slope. Let's continue finding slope. I want to find the slope of the line through these 2 points. So we use the slope formula. Remember, y minus y over x minus x. I'll choose this y first. -2 minus 5 over, now I must place this x value first, minus, and then -1. So -2 minus 5, that is -7, over 6 minus a -1, that's 6 plus 1, or 7, and that simplifies to -1. So the slope is -1. Let's look at a diagram. We just found the slope of the line connecting these 2 points to be -1. I want you to realize something. As I move along the line from left to right, notice I'm moving downward, and that downward movement does have to do with a negative slope. Let's now find the slope of the line through these 2 points. We'll use that same slope formula. Slope is equal to y minus y over x, negative 4, be careful, minus this x value, negative 4. Let's see what we have. 5 minus 3 is 2, and negative 4 minus a negative 4 is negative 4 plus 4, and that is 0. So we call this, remember, undefined. We cannot divide by 0. So we say the slope here is undefined. Let's look at a diagram to see what kind of line goes through these 2 points. Here is a look at the line through this point, negative 4, 5, and negative 4, 3. We just found the slope of this line. We found it to be undefined. So a vertical line in general has undefined slope. Let's find one more slope. Let's find the slope of the line through these 2 points. Remember how to find slope. Y minus y over x, negative 2, minus x of 5. Let's see what we have. 1 minus 1 is 0 over negative 2 minus 5, that's negative 7, but 0 in the numerator is okay as long as it's not 0 in the denominator. 0 over negative 7 is 0. This slope is 0. Let's see what the line through these 2 points looks like. Here is the line through negative 2, 1 and 5, 1. Notice it is a horizontal line. We just found the slope of this line to be 0, so the slope of horizontal lines is 0. Thus far, we know the slope of a line measures its tilt. We also know how to find the slope given 2 points. But there's another way of finding slope given the equation of the line, and that is by the slope-intercept formula. Let's look at that slope-intercept form. When a linear equation in 2 variables is written in slope-intercept form, y is equal to mx plus b, m is the slope of the line, and 0b is the y-intercept of the line. So let's use the slope-intercept form to find the slope of the graph of this equation. Basically, the slope-intercept form is the form we get when we solve the equation for y. So just keep that in mind. Slope-intercept form means solve the equation for y. How can I solve this equation for y? I will subtract 2x from both sides, and I'll have y equals then negative 2x plus 7. When an equation is solved for y, the coefficient of x is the slope. So the slope of the graph of this equation is negative 2. And by the way, what's the y-intercept? The y-intercept is the point 0, 7. So there's the slope, there's the y-intercept. Let's try this one more time. Let's find the slope of the line defined by 2x minus 3y is equal to 10. We'll use the slope-intercept form. To use the slope-intercept form, we solve this equation for y. To solve it for y, I will subtract 2x from both sides. So on the left side, I'll have negative 3y. On the right side, I'll have negative 2x plus 10. Now, how do I finish solving for y? I divide each term by the coefficient of y, which is negative 3. So I'll divide by negative 3, divide by negative 3, divide by negative 3. Now, by the way, we sometimes simply divide both sides of the equation by negative 3. That is the same as dividing each term of the equation by, in this case, negative 3. Now, on the left side, I have y is equal to, I'll write that as 2/3 x plus a negative 10/3 or minus 10/3, however you'd like to write it. This is now slope-intercept form. What is the slope of the graph of this equation? It is the coefficient of x. So the slope is 2/3. Now, by the way, just for practice, what is the y-intercept? It's 0, b, and b is negative 10/3. So there's the slope of the graph of that equation, and there is the y-intercept. Thus far, we know the slope formula. We also know the slope-intercept form. Let's now find the slope of a few special cases. What kind of a line is this, x is equal to 1, if I were to graph this line? Remember, x is equal to a constant. That is always a vertical line. So this is a vertical line, but I'd like to find the slope. We can do so by using 2 points and using the slope formula. For example, we know as long as x is 1, we have an ordered pair solution of this equation. So I'll just choose 1, 0 and say 1, 5. Makes no difference as long as x is 1. So here I have 2 points on the graph of this equation. Let's find the slope by using the slope formula. It is y minus y over x minus x. And this should be familiar to you because we've talked about it a little bit. I have 5 over 0. This is undefined. It is true then, vertical lines have undefined slope in general. So now you don't need to calculate it anymore. If you have a vertical line, the slope is undefined. Let's now also look at a horizontal line. Now, a horizontal line has a general form, y is equal to a constant. Here is my equation. Let's now find the slope of this special type of line. What type of line is it again? It is a horizontal line. So we're going to find the slope by using the slope formula. Let's write down a few points that are ordered pairs of this, or ordered pair solutions of this equation. As long as y is negative 3, I do have an ordered pair solution. So I can let x be, say, 0, I can let x be 2, I can let x be any number I want as long as y is negative 3. Let's now use our slope formula. Now be careful, it's y minus y over x minus x. And now let's calculate what is negative 3 minus a negative 3. That is negative 3 plus 3, which is 0 over 2 minus 0 is 2. That does simplify to 0. So the slope of this horizontal line is 0. You don't need to calculate the slope of horizontal lines any longer then. If you have a horizontal line, its slope is 0. Let's now review the appearance of lines with certain slopes. If a line has a positive slope, if m is greater than 0, as you move from left to right, the line moves upward, or we say we have an upward line. If your line has a negative slope, if m is less than 0, as you move with your line from left to right, you move downward, or you say you have a downward line. If your line has a 0 slope, m is equal to 0, you have a horizontal line. An undefined slope or no slope, the line is a vertical line. Now that we've talked about how lines tilt, now that we've talked about their slope, let's talk about parallel and perpendicular lines. Doesn't it make sense to you that since parallel lines never meet, they must then tilt the same way, and if they tilt the same way, they have the same slope? That is true in general. Let's look at the following. Non-vertical parallel lines have the same slope and different y-intercepts. And what about perpendicular lines? If the product of the slopes of two lines is -1, then the lines are perpendicular. In other words, two non-vertical lines are perpendicular if the slope of one is the negative reciprocal of the slope of the other. Let's review that by comparing lines. In other words, I want to know, are the graphs of these two lines parallel lines, perpendicular lines, or neither? To find out, let's simply compare slopes. Now notice, each of these lines is written in slope-intercept form, so I know the slope of this line is 2/9, and I know the slope of this line is -2/9. Now these slopes are not the same, so we do not have parallel lines, and we can check and see if the product of these two slopes is -1. You can check, but this product is not -1, so we don't have perpendicular lines. These lines are neither parallel nor perpendicular. Let's try again. Let's look at two lines. Let's suppose I have 10 plus 3x is equal to 5y, and I have, say, 5x plus 3y is equal to 1. I'd like to know about the graphs of these lines. Are they parallel lines, perpendicular lines, or neither? To see, we need to write each in the slope-intercept form. So I'll take this line and I'll write it in slope-intercept form by solving it for y. Now notice I have 5y by itself, so I simply need to divide through by 5. So I'll have 10 divided by 5 plus 3x divided by 5 is equal to 5y divided by 5. Or 10 divided by 5 is 2 plus, as a matter of fact, if you don't mind, let's go ahead and write it under here. 2 plus 3/5 x is y. And now I'm going to go ahead and write the y first, so you can see it in that exact slope-intercept form. Then I'll have y is equal to 3/5 x plus 2. Here is this equation written in slope-intercept form. I'll erase my work, and I'm now going to concentrate on the second equation and writing it in slope-intercept form. So there's that equation, and now I'll work on the next one. How do I solve this equation for y? I will subtract 5x from both sides, so I'll have 3y is equal to -5x plus 1, then finish solving for y by dividing through by 3. So I'll divide every term by 3, and y is -5/3 x plus 1/3. There it is written in slope-intercept form. So let me write that down. It is y is equal to -5/3 x plus, and then that was 1/3. Now that I have each equation written in slope-intercept form, what is the slope? Here the slope is 3/5, and then here the slope is -5/3. Now, are these two lines parallel? The answer is no, because the slopes are not the same. Are they perpendicular? The answer is yes, because the product of these two numbers is 1, because 3/5 times -5/3 is -1. We know then that these two lines are perpendicular lines. All right, so the graphs of these two lines happen to be perpendicular lines. Now that we know how to calculate slope, let's look at an application and let's view slope as a rate of change. Let's look at the following. The graph shows the total cost Y in dollars of owning and operating a compact car, of course excluding the cost of the car, where X is the number of miles driven. So notice we have this line graph, and notice we have 2 points with ordered pairs noted. So we'll use those 2 given points or those 2 given ordered pairs to calculate slope. So there are our 2 ordered pairs that were given. We'll find slope just as usual. How do we find slope given 2 ordered pairs? Slope is y minus y over x minus x. So y, 9,400, minus y, 2,350, over x, 20,000. Remember, x had to do with miles and y has to do with cost. There we go. So if you subtract, let's see, that's 7,050 over 15,000, and then divide, and you'll have 47 hundredths. So that's 47 cents, but that's my slope, and we'll look at it as a rate of change. So think of it as maybe this amount of money over 1. Remember now, this denominator, which is what? The x values, that has to do with miles. So what does that mean? It means that it costs this much money per 1 mile to own and operate. And this is how we're viewing slope, as a rate of change. And that's how we're writing it in this application. It costs this much money, remember those are the y values, money, per 1 mile to own and operate. I think it's a compact car. All right, at this time, practice calculating slope and looking at slope as a rate of change. Let's check your understanding of the slope-intercept form by answering the following question. What is the slope of the graph of 3y is equal to negative 2x plus 6? Is it choice A, is the slope negative 2? Is it choice B, is the slope 2? Or is it choice C, is the slope negative 2/3? Take a moment, the video will stop, and then make your selection. Choice A is incorrect. Let's talk about why. For an equation to be written in slope-intercept form, this equation must be solved for y. Once it's solved for y, then the coefficient of x is slope. This equation is solved for 3y. We need to solve it for y, and how do we do so? We divide every single term by 3, the coefficient of y, and then we have y is equal to negative 2/3 x plus 2. So the slope of that equation is negative 2/3. The correct choice is choice C. Slope is negative 2/3. Once again, C is the correct choice. B is incorrect. Let's talk about why. To have this in slope-intercept form, this equation must be solved for y. So let's take that equation and let's solve it for y by dividing through by 3 every term, dividing by 3, and y is equal to negative 2/3 x plus 2. So the y-intercept is 0, 2. The slope is choice C. The slope is negative 2/3. C is the correct choice. Choice C is the correct choice. Let's talk about why. To write this equation in slope-intercept form, remember it must be solved for y. To solve this equation for y, you divide each term by 3. Once you divide this term by 3, then the coefficient of x is negative 2/3. So C is the correct choice.